2. Good day, everyone. Today we shall be considering mathematical induction. By the way, this is Gifted Brain, aka Saizu, first in Africa, sixth in the world. Example 2, prove by induction summation of r squared starting from r equal to 1 till n, and that it is equal to n into n plus 1 into 2n plus 1 all over 6. And so, first of all, I want to say that this question can be written as very, very important. Express it in that form. It makes your work easy and comprehensive when you are solving actually. So I will have 1 square and then plus 2 square plus 3 square. That's what it means. On and on till n square plus n square. Yes. And it is equal to n into n plus 1, 2n plus 1 all over 6. Yes, this is what it gives to us. So first of all, our step 1, that is the first thing to do. Step 1, let n be equal to 1. Obviously, if n equal to 1, our left hand side will give me 1 square. And then that 1 square means 1. And then you go to your right hand side. We have substituting 1 into what we have. So this is what we have. And then we'll go ahead to simplify. That'll be 1 into 2 now. For 1 plus 1 is 2. Then into 2 times 1 plus 1 will give me 3 all over 6. So you can see that we have 1 also. So on the right hand side, we have 1. On the left hand side, we have 1. So the step 1 has satisfied the condition we need it to satisfy. So the next thing we do is to move to step 2. So step 2. In step 2, we say let n be equal to k. If n is equal to k, what we have is 1 square plus 2 square plus 3 square plus on and on till we get to k square. And that will give us k into k plus 1 into 2k plus 1, then all over 6. Yes. And then lastly, we move to step 3. And that step 3 says let n be equal to k plus 1. So obviously, with this, what we have, or what we should have, is saying 1 square plus 2 square plus 3 square plus on and on, plus k square. And then finally, we're not something like k square, we're something like k plus 1 square. So this is what we have, k plus 1 square. And that should give us, on the left hand side, on the right hand side, anywhere we have n, substitute k plus 1 into it. So we have k plus 1 instead of having just n, first of all. And then I will have k plus 1 again, plus under 1 over, then again 2 into k plus 1. You see what I'm doing now? Substituting, anywhere I see n, substitute, or you say, anywhere you see this k, change to k plus 1. You can also use that. Anywhere you see this k, just change to k plus 1 because it was n that was there before. And so then plus 1. Instead of just scrolling up to can see the equation that has the n, we can just use this directly. And so at the end of the day, you see, from here, if you simplify this right hand side, you will have k plus 1 and then k plus 2 now. Take note. And then finally, you will have 2k plus 3 all over 6. And so this is what we would have. And so you can simply, let's now see, can we work on our left hand side to give us what we have on this right hand side? That's what we just want to do. But recall briefly that from here again to this k square, in this step 2, it gave us k into k plus 1, 2k plus 1 all over 6. And so, but now we added k plus 1 all squared. And so let's see if we can make this to be equal to the right hand side. So I just make this over 1 and then find the LCM. Obviously the LCM is 6, so you say 6 into, now 6 into 6 times 1 will give me everything on this part. So we have this, and so this is what we have, because you say 1 into 6, that is 6 multiplied by the numerator. I split the numerator into k plus 1, because it's having square. And so now as you look at this side, and look at this side, what do they have in common? Obviously they have in common k plus 1. They have in common k plus 1. So I'm going to factorize that k plus 1 out. If I factorize that k plus 1 out, what will be left there will be the first k here, this k here, and then the 2k plus 1. That will be left there. And then on this right hand side, if we also factorize, so let me use okay, that's okay. Now also on this what's it called now? Okay, let's pause a little bit. Let me make some correction. Okay, let's bring out the common term again, please. Okay, so the common term is k plus 1. I put that in brackets, and then if I bring out k plus 1 from this side, I'll be left with k into 2k plus 1. And then on this other side, if I bring out k plus 1, I'll be left with 6 and 1k plus 1. Yes, so this is what we have on this side. Remember, all over 6. So at the end of the day, we can further simplify by saying we have k plus 1 out. Open up that bracket. Open up the brackets you have. You have 2k squared plus k plus 6k plus 6. Everything all over 6. So at the end of the day, also, I would have k plus 1 in bracket 2k squared plus 7k plus 6 all over 6. So what will happen is that we now try to factorize this 2k squared plus 7k plus 6. Obviously we can use 3 and 4k. Let me just show the factorization for clarity's sake. So we have in brackets 2k squared now plus 3k plus 4k and then plus 6. Everything again all over 6. And then if we factorize this now, we should have okay, k plus 1 firstly. Then let's try to factorize this. What is here should give us, what is here should give us, first of all, what is common between this is k. Factorize k, you have k plus 2k, 2k plus 1 plus 3, and then factorize on this other side, which is 2 is common, you will have 2k again plus 3, our normal factorization. At this level, everybody should be able to factorize before you get to say you are doing mathematical induction. Okay, so over 6. So at the end of the day, we have k plus 1. We have many end of the day, don't mind me. So we have what is common on both sides is 2k plus 3. So 2k plus 3 in bracket again k plus 2. So you can see over 6. I can rearrange this now to give us k plus 1 and then k plus 2. I've rearranged now, and then 2k plus 3 all over 6, which is what we have on the left and on the right hand side. You can check that this is what we have on the right hand side. So we've been able to prove. We just write proved. We've been able to prove that this is what we should have. So that